we need to find the value of the integral a to b root x upon root x plus root of a plus b minus x dx. So let us consider to be this is I, and by using the properties integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So let us use this property here. We can write integral a to b under root of, in place of x we have to substitute a plus b minus x, a plus b minus x divided by under root of, we can write a plus b minus x plus, and a plus b minus x will become x dx. So let us consider this is 1 and say this is 2. Adding 1 and 2, adding 1 and 2, we get 2i is equal to, both the limits are same, we can write a to b root x plus root of a plus b minus x divided by root x plus root of a plus b minus x dx. So both are same, we can get cancel. So we get 2i is equal to integral a to b 1 dx, and integration of 1 dx is x and over the limits a to b. So we can write 2i is equal to, or I is equal to 1 upon 2 times of upper limit is b minus lower limit is a. So half of b minus a is the answer. So we can go with an option B. Integral e to the power x square into 2x plus x power 3 upon 3 plus x square whole square dx. So we can write integral e to the power x square taking x common. So we'll get 2 power x square times x dx upon 3 plus x square whole square. So let us substitute. Put x square is equal to t. On differentiating, we'll get 2x into dx is equal to dt, or we can write x dx is equal to 1 upon 2 dt. So we may write here e to the power of t into 2 plus t upon 3 plus t whole square into x dx. We can write it as x dx is 1 by 2 dt. So we may write here 1 upon 2 dt. This can also be written 1 by 2 times integral e power t into, and 2 plus t we can write it as 3 plus t minus 1 upon 3 plus t whole square. So which is equal to 1 upon 2 times integral e power t into 3 plus t upon 3 plus t whole square minus 1 upon 3 plus t whole square dt. So which is equal to 1 by 2 integral e power t into 1 upon 3 plus t minus 1 upon 3 plus t whole square. And we know that integration of, our differentiation of 1 upon x is d by dx of 1 upon x is minus 1 by x square. So here differentiation of 1 upon 3 plus t can be taken as minus 1 by 3 plus t whole square. So it is in the form e power x into f of x plus f dash of x dx. And we know that integration e power x into f of x plus f dash of x dx is e power x into f of x plus c. So here this function is f, and minus 1 by 3 plus t whole square is f dash. So we can write 1 by 2 e to the power of t into f of t dt. The f of t is nothing but 1 upon 3 plus t. So we can add 1 upon 3 plus t plus constant. Let us substitute back t is equal to x square. So 1 by 2 e to the power of x square into 1 upon 3 plus x square plus some constant c. So we can go with an option here. Second one d e power x square upon. So option D is the answer. If integral 0 to a f of 2a minus x dx is equal to m and 0 to a f of x dx is equal to n, then we need to find integral 0 to 2a f of x dx. So let us consider integral 0 to f of 2a minus x dx. Let us simplify by substituting 2a minus x is equal to some t. So differentiating with respect to 2x, we get minus dx is equal to dt or dx is equal to negative t, and also whenever x is equal to 0, the lower limit. So we can write 2a minus x is equal to t, that is 2a minus 0 is equal to t. So we get t is equal to 2a, and whenever x is equal to a upper limit, so we get t is equal to 2a minus x, that is a, which is equal to a. So we got t is equal to a. So we can write the limits as integral. When x is 0, we'll get 2a, and when x is equal to a, it is a to a to a to a f of t, and dx is equal to negative dt, which is equal to m. So here we can write, so minus negative 2a to a, we can also write it as integral a to 2a, changing the sign, f of t dt is equal to m. This can also be written a to 2a. Instead of t, we can write the variable change in variable does not affect integral in limits. So is equal to m. So let us consider this as 1, and also now, and integral 0 to a f of x dx is equal to given n. Make this as 2. Now consider integral 0 to 2a f of x dx, which is equal to, we can write 0 to a f of x dx plus a to 2a f of x dx. So from second, we can write 0 to f of x dx is n, and a to 2a f of x dx is equal to m. So we can write from 1 and 2, because from 0 to a, we can write from 0 to 2a, it is divided into two equal parts, 0 to a and a to 2a. So equal area. So we'll get 0 to a plus a to 2a. You're getting answer n plus m, which is option D. Let us consider integral I is equal to cos x minus 1 upon 1 plus sin x into e power x dx. So we can write here I is equal to cos x into e power x divided by 1 plus sin x dx minus e power x upon 1 plus sin x dx. So let us consider this is the first function I1 and this is I2. So we can write I is equal to I1 minus I2. Consider the function I1 integral e power x into cos x upon 1 plus sin x dx. Let us apply the by parts f and g rule. So cos x upon 1 plus sin x is the first function and e power x is the second function. So we have integral fg is equal to f integral g minus integral of f dash into integral of g. So I1 is equal to integral, or we can write f into, that is cos x upon 1 plus sin x into integration of e power x is e power x minus integral of differentiation of, that is d by dx of cos x upon 1 plus sin x into integral of e power x is e power x dx. So I1 is equal to cos x or e power x into cos x upon 1 plus sin x minus integral of differentiation of cos x upon 1 plus sin x. Let us use u by v rule. So we can add 1 plus cos x whole square. So 1 plus cos x into differentiation of cos x is negative sin x and minus again cos x into differentiation of 1 plus sin x is cos x into e power x dx. So I1 is equal to e power x cos x upon 1 plus sin x minus, and here we can write integral 1 into negative sin x is minus sin x, and this is, sorry, this is sin x, sorry. This is 1 plus sin x. So we can add negative sin x here and minus sin square x, and again here minus cos square x. So if minus is taken common, sin square x plus cos square x, we can take it 1. And denominator 1 plus sin x whole square. This is not cos x, sin x. So we can add 1 plus sin x whole square. So I1 is equal to e power x into cos x upon 1 plus sin x minus of minus taken common. We can write 1 plus sin x upon 1 plus sin x whole square. So 1 plus sin x we can take cancel, and we can write I1 is equal to e power x into cos x upon 1 plus sin x, and here again, sorry, there is an e power x dx. E power x upon 1 plus sin x is nothing but your I2. So e power x upon 1 plus sin x integral is I2. So I can write this is plus I2. So I1 minus I2 is equal to e power x into cos x upon 1 plus sin x plus integral constant c we can take. So I1 minus I2 means our integral I. So therefore I is equal to, our integral is equal to e power x into cos x upon 1 plus sin x plus c, which is option A. We can go with an option A. We need to find the integral 0 to n step x dx, that's the integral part function, and upon integral 0 to n fractional part function dx. We know that integral 0 to n, when n is a natural number, step x dx, that is fractional part function, can be taken as n into n minus 1 upon 2. And now the relation between the step function and the fractional part function, every real number we can write it as a sum of integral part plus fractional part. So which implies fractional part we can write it as x minus step x. And now integral 0 to n fractional part of x dx is equal to integral 0 to n x minus step x dx, which is equal to integral 0 to n x dx minus integral 0 to n step function dx. We know integration of x dx is x square by 2 over the limits 0 to n minus integral 0 to n step x is n into n minus 1 by 2. So we can write n square upon 2 minus n into n minus 1 upon 2. So you can take 2 common in the LCM, or here n square minus of n taken common 1 minus of n plus 1, or else we can write simplify n square minus n square minus of minus plus n divided by 2. So n square get cancelled. So we are getting n upon 2. So therefore integral is 0 to n integral part function dx upon integral 0 to n fractional part of x dx is equal to n into n minus 1 upon 2 divided by n by 2. So n upon 2 gets cancelled here. So we are getting the answer only n minus 1. So we can go with an option D. We need to find the slope of the tangent to the curve y is equal to integral x to x square cos inverse t square dt at x is equal to 2 to the power of minus 4. Means we need to find dy by dx at the point x is equal to 2 to the power minus 1 by 4. So here we can write differentiating with respect to x, we have dy by dx is equal to d by dx of the integral x to x square cos inverse t square dt, which is equal, we know that by Leibniz rule d by dx of integral f of x to g of x h of t dt, which is equal to, we can add h of g of x into g dash of x minus h of f of x into f dash of x dx, f of f dash of x. So let us apply here. We'll get cos inverse of x square whole square into differentiation of x square is 2x minus integral of, not integral, cos inverse of x square into differentiation of x square is, differentiation of x is 1, and then we can write dy by dx is equal to 2x into cos inverse of x power 4 minus cos inverse of x square. And now you need to find the slope dy by dx at the point x is equal to 2 power minus 1 by 4 is equal to 2 into 2 power minus 1 by 4 into cos inverse of 2 to the power of minus 1 by 4 whole power 4 minus cos inverse of 2 to the power minus 1 by 4 whole square. So we can write 2 to the power 1 minus 1 by 4 is 3 by 4 into cos inverse of 2 to the power of minus 1, that is 1 by 2, minus cos inverse of 2 to the power of minus 1 by 4 whole square is 2 to the power minus 1 by 2, that is 1 by root 2. We know that cos inverse of 1 by 2 is cos pi by 3. So 2 to the power of 3, that is 8, 8 power 1 by 4 we can write here. So we can write 4th root of 8 into cos inverse of 1 by 2 is pi by 3 minus cos inverse of 1 by root 2 is pi by 4. Or you can take, we can take pi common, and fourth root of 8 divided by 3 minus 1 by 4 of pi is the answer, which is our option C. We need to find limit extends to infinity 0 to 2x integral x into e power x square dx upon e power 4x square dx. When we apply x is equal to infinity or extends to infinity, so it is infinity by infinity form. So we can use L'Hospital rule, LH rule, that is differentiating numerator and denominator separately. So we get limit extends to infinity d by dx of integral 0 to 2x x into e to the power of x square dx divided by d by dx of e power 4x square, so which is equal to limit extends to infinity, and we know the by Leibniz rule integral f of x to g of x h of x dx is equal to h of g of x into g dash of x minus h of f of x into f dash of x. So let us apply here. We can write 2x into e to the power of 2x whole square into differentiation of 2x is 2 minus h of z, that is 0, we can write 0, divided by differentiation of e power 4x square is e power 4x square into differentiation of 4x square is 8x. So we can write limit extends to infinity 2 to the 4x into e to the power 4x square divided by 8x into e to the power 4x square. So we can cancel e power 4x square and x and 4 two times. So you're getting limit extends to infinity 1 upon 2, which is constant. So you can add 1 by 2. So 1 by 2 is the answer, which is our option D. D is the answer. Given a polynomial of degree 3, f of x, satisfying f of 0 is negative 1 and f of 1 is equal to 0. So let us consider third degree polynomial f of x is equal to ax power 3 plus bx square plus cx plus d, and it is given f of 0 is equal to negative 1, which implies a into 0 power 3, that is 0, plus b into 0 square is 0, plus c into 0 plus d is equal to negative 1, which implies d is equal to negative 1. And also f of 1 is equal to 0, which implies that a into 1 power 3 plus b into 1 square plus c into 1 plus d is equal to 0, which implies that a plus b plus c plus d is equal to 0. So from this both, so here we can write, since d is equal to negative 1, we can write that a plus b plus c is equal to plus 1. And now 0 is a stationary point of f of x and f of x does not have extremum. Since 0 is a stationary point, so we can consider f dash of x is equal to 0 at x is equal, that is f dash of 0 is 0, and also f double dash of 0 is also 0. So let us find f dash of x. We have f of x is equal to ax power 3 plus bx square plus cx plus d. Now f dash of x is equal to 3ax power 2 plus 2bx plus c, and f double dash of x is equal to 6ax plus 2b, and f triple dash of x is equal to 6a. So here we can write f dash of 0 is equal to 0, which implies that 3a into 0 plus 2b into 0 plus c is equal to 0, which implies c is equal to 0. And similarly f double dash of 0 is equal to 0, which implies that 6a into 0 plus 2b is equal to 0, which implies that 2b is equal to 0, that is b is equal to 0. And we have to make sure that f triple dash of 0 is not equals to 0. So which implies that f triple dash of x is 6a, so a is not equals to 0. And now substituting b is equal to 0 and c is equal to 0 here, you will get a is equal to 1. So we got a value 1, d value is negative 1. The rest of the terms are 0. So we can write, therefore f of x is equal to 1 x power 3 plus 0 x square plus 0x minus 1, which is equal to x power 3 minus 1. Now consider integral f of x, that is x power 3 minus 1 upon x power 3 minus 1 dx is equal to integral of 1 dx, which is equal to x plus some constant c. So we can say that x plus c is the answer, which is equal to x plus c. Evaluate integral 1 upon 1 plus 3 sine square x plus 8 cos square x. So here there are two terms, sine square x and cos square x. Let us convert into secant square and tan square x. So dividing with the cos square x, so we get 1 upon cos square x dx upon 1 plus 3 sine square x plus 8 times cos square x divided with cos square x. We can add 1 upon cos square is secant square x upon, this is secant square x plus 3 times of tan square x plus 8. Again we can convert secant square x is 1 plus tan square, because we have secant square theta minus tan square theta is 1. So we can write integral secant square x upon 1 plus tan square x plus 3 tan square x plus 8 dx. So integral, or here we can write secant square x dx upon 4 tan square x plus 9. Put tan x is equal to t. So we get secant square x dx is equal to dt. So integral dt upon 4t square plus 9. We can also write dt upon 4 taken common, t square plus 9 by 4, that is 3 by 2 whole square. And we know the integral dx upon x square plus a square is equal to 1 upon a tan inverse of x upon a plus constant. So here we can write 1 upon 4 into 1 upon a, that is 1 by 3 by 2 tan inverse of a by a, that is t divided by 3 by 2 plus c. Or we can write, so 1 upon 6 times tan inverse of 2 into t value is tan x upon 3 plus c. So which is option C. 1 by 6 tan inverse of 2 tan x divided by 3 plus c. Option C we can go. Let us consider integral I is equal to 0 to 10 x power 10 upon 10 minus x whole to the power of 10 plus x power 10 dx. Let us use the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. So here we can write integral 0 to 10 minus x power 10 divided by 10 minus x will become x power 10, and here again 10 minus x whole power 10. So I is equal to, or let us take it as one equation. This is 1 and this is 2. Adding 1 and 2. So we get 2I is equal to integral 0 to 10 x power 10 plus 10 minus x whole power 10 divided by x power 10 plus 10 minus x whole power 10 dx. So we write, so we have 2I is equal to integral 0 to 10 1 dx, that is I is equal to 1 upon 2, and here we can write integration of 1 dx is x over the limits 0 to 10. So 1 by 2 times of upper limit minus lower limit, that is 10 upon 2, which is equal to 5. So the value of integral I is 5 units, so we can go with an option B. Integral x square minus 1 upon x square plus 1 into root of x power 4 plus 1 dx. So we get x square taken common, 1 minus 1 upon x square divided by, and here we can take x common, x plus 1 upon x into again under root of, so here x square is taken common, so x square plus 1 by x square dx, which is equal to x square into 1 minus 1 upon x square divided by x times of x plus 1 upon x, and root of x square will bring x outside, so we'll get root of x square plus 1 by x square dx. So here we can cancel x square and x square in the numerator and denominator, and we know that the differentiation of x plus 1 upon x d by dx of x plus 1 upon x is 1 minus 1 by x square, and also x square plus 1 by x square we can write it as x plus 1 upon x whole square minus 2. So let us write here integral 1 minus 1 upon x square dx divided by x plus 1 upon x into under root of x plus 1 upon x whole square minus 2, which is under integral. So differentiating or by substituting x plus 1 upon x is equal to t, so you'll get 1 minus 1 upon x square dx is dt. So we get dt upon t into under root of t square minus 2, we can write it as root 2 whole square. And we know that integral dx upon x root of x square minus a square is equal to 1 upon a secant inverse of x upon a plus c. So we can write here 1 upon root 2 into secant inverse of t divided by root 2 plus c, or we can write 1 upon root 2 secant inverse of t value is x plus 1 upon x upon root 2 plus c, and on simplification we will be getting 1 by root 2 secant inverse of x plus 1 upon x, we can write x square plus 1 upon x into root 2 plus c, which is our option B. So option B is the answer.